Hello everyone, I'm Anushri here from ECE department. Uh, Let us start. In this video, let us study about module 3, that is operational amplifiers. In the operational amplifier, we are going to study about the introduction to the op-amp, then operational amplifier input modes, its parameters, and then the application of op-amps. That is, it could be used as an inverting amplifier or a non-inverting amplifier, a summer, or a voltage follower, differentiator and a followed by differentiator and a comparator. So first have a look at the introduction. Let's have an introduction to op-amp. An operational amplifier is mostly commonly referred as an op-amp. Shortly we call it as an op-amp. It is a direct coupled multi-stage voltage amplifier with extremely high gain. Its behavior can be controlled by adding suitable feedback to this. The name of op-amp was derived from the fact that the amplifier was originally used to perform mathematical operations, such as it could perform addition, subtraction, integration, multiplication, and differentiation. The symbol of the op-amp is as shown here. It is going to consist of a triangular, basically by a triangle, which indicates the direction of signal flow, All the op-amps are going to have minimum of 5 terminals. First one is the positive supply voltage, that is V1, positive supply voltage, and second it is a negative supply voltage, and the output terminal V out, and we have the input voltages V1 inverting input terminal and the non-inverting input terminals. The positive input voltage is plus VCC and the negative input voltage is minus VEE. Okay, so this is how it is represented. The symbol is represented using a op-amp. Let us study about the pin diagram. The pin IC MUA741 stands for op-amp, that is operational amplifier. This is an 8-pin IC where the first pin stands for the offset null and the second pin stands for an input terminal, inverting input terminal. Third pin stands for a non-inverting terminal and the fourth pin stands for minus VEE. Your fifth pin stands for offset null and the sixth pin stands for output. Seventh pin stands for plus VCC and the eighth pin stands for no connection. There would be no connection for the pin number 8, which is going to act as a dummy pin. Now let us study about the architecture or the block diagram of a IC MUA741. The block diagram of an op-amp is as shown here. Basically, the first block of the IC MUA741 or the op-amp consists of a differential amplifier, which is going to amplify the signal, that is amplify the difference between the two input signals, that is V1 and V2. The differential amplifier which has got a high input impedance. Okay, the overall gain requirement of the op-amp is very high. The differential amplifier stage cannot provide this gain. So as a result, we have an high gain amplifier, that is the gain stage which I am showing here. The main function of this high gain amplifier is to provide additional gain required when there is no signal applied at the input terminals. The level shifter stage brings the DC level down to the ground potential. The signal is then given to the last stage, which is driver stage, or we call it as a buffer stage. So this is what is the block diagram of op-amp. Now let us move on to the ideal characteristics. Ideal is nothing but it is a condition where we take all the other where we take all the parameters to be equal to 0. So when we go for the ideal parameters, we say first as our operational amplifier should possess infinite open loop gain, that is gain is given by a formula V out by V in, that is represented by G. Now it should possess an infinite open loop gain. Then it should possess an infinite input impedance R such and zero input current. It should have a zero input offset voltage, zero output voltage range, infinite bandwidth should be there, and zero output impedance, zero noise, infinite common mode rejection ratio, infinite power supply rejection ratio. Along with that, the temperature should it is independent of temperature, right? So this is about the ideal characteristic of an operational amplifier, that is it is going to possess, that is always remember A, that is the open loop gain A should be equal to infinity. Input impedance Ri should be equal to infinity, and the bandwidth, that is bandwidth should be equal to infinity. Common mode rejection ratio CMRR, then the power supply rejection ratio PSRR should be equal to infinity. Then input offset current and bandwidth is also equal to infinity. Input offset current should be equal to 0. So these are all the ideal characteristic of an op-amp where the op-amp should possess. So this is about the ideal characteristic of a operational amplifier. Now let us have a look into the operational amplifier input modes. An op-amp is going to consist of, we already know an op-amp is going to consist of two input terminals. One is an inverting terminal and the other one is a non-inverting terminal. So for the in order to an op-amp is going to consist of two or more differential amplifiers at the initial stage. The basic differential amplifier circuit is it is like it is as shown, that is it is going to have two terminals V1 and V2, which is V1 is your inverting terminal with a negative sign and non-inverting terminal is the positive sign. The operational amplifier works in different input modes. They are the single-ended mode, differential mode and the common mode inputs. So when we come for the single-ended mode, we can have a look here. That is, in your single-ended mode, we have the operational amplifier. For the operational amplifier, my V in is given to the inverting terminal, non-inverting terminal of the input, and my inverting terminal is grounded. So when we go for the single-ended input, it says that for the one of my input we are going to provide, that is in this mode the signal voltage is applied to one of the input that and the other input should be grounded. It could be given either to the non-inverting terminal or it could be given to the inverting terminal, but only the input is provided for only one of the input terminal and the other input terminal should be grounded. So this is where, so when we give for the non-inverting terminal, we expect the same output, right? So what is going to happen here in this single-ended mode and the input modes, we are going to possess two outputs, that is V01 and V02. So when we give the output, when we give the inputs to V01 and V02. V01 is going to provide me an inverted output and V02 is going to provide me the same output. Okay, so this is about the single-ended mode. Now let us go for the other mode of input. Okay, that is differential input mode. For the differential input mode, we can have a look at the differential input mode. In this mode, two out of phase signals, that is in the two out of phase or two out of phase signal voltages are applied to the inputs of the differential amplifier. This type of operation is also called as double-ended input operation. We call this as double-ended operation, a double-ended input operation, right? So the basic principle of the behind this differential mode is the superposition. The output is equal to the sum of the individual outputs, right? The individual output V out 1, that is V01, and V02 in each case are added up and the total output is doubled. So in this mode, the two opposite polarity signals are applied to the inputs and this operation is referred to as double-ended operation, right? Now let me go for the other kind of input mode, that is the common mode. In this common mode, we are going to apply, in this mode, in phase signal, that is we are going to apply both the signals which are in same phase, that is we apply the voltages, signal voltages which are in phase is applied to the input terminals of the differential amplifier. Now as a result, by superposition, applying the superposition theorem or the superposition principle, the individual outputs, that is V01 and V02 in each case are added up and the total output becomes 0. So as a result, the common input mode will not find application and it is found in very rare applications. Hope this is the bibliography where I have taken most of the contents. I hope this video is useful to you and it gives an immense knowledge. Thank you.